Hi, my name is Amy Rizzo, and this is my observation video. I want to tell you who I observed. I observed Kim Derricks. She was teaching summer school. It was really unfortunate that I had to do this observation video over the summer because it didn't give me a whole lot of opportunities, but I still caught a summer school class. This class had 6 students in it. The students were those kids, those 8th grade students that did not pass math. So this was a 8th grade summer school math class. The boys, there were I'm sorry, there were 5 students. I'm messed up. There were 3 boys and 2 girls. They were sitting kind of in a half horseshoe, boy, boy, girl, girl, boy, with a little bit of space in between them. Each of these kids were on RTI. They had some kind of 504 plan to get them back to where they needed to be. The first thing that you're going to see is her going over the warm-up. She was very specific in what they had, what was required for their class. Like they had journals. She asked for their journals to be, or their table of contents to be very specific, and she made them show proof. The reason why I chose this video is Ms. Derricks is very good at using the interactive whiteboards. Interactive whiteboards, they kind of a lot of people overlook them as a use for technology because they just use them to write on the board. It's amazing to me how many different districts have interactive whiteboards, whether it be a smart board or Promethean board, and they don't provide enough training on these boards to really use the tools and show what all these boards can do if you are familiar with the technology. Ms. Derricks is quite familiar with the technology and uses the math tools, and in this situation uses the protractor for the kids to actually move left and right and slide it around to actually measure their angles to determine if angles are equal, if they are vertical, corresponding, supplementary, those kind of things. And she lets each child come to the board, so all the kids are using this technology. They also have protractors on their desk. They also have scissors that they're cutting things out. It's very hands-on, this lesson. And this was not her normal school. Our district held summer school in an elementary school. So you have these big boys using these little bitty scissors. So that was kind of frustrating to her that it was not her normal classroom, but it still worked. It still worked. She is really good about asking for previous knowledge. She did show a video from YouTube. Unfortunately, with YouTube, you don't always know what's going to pop up. So sometimes YouTube is not the safest. So you might see a little bitty oops in there and how she recovered from that. But it kind of added a little comic relief, I guess. And 8th grade kids think it's hilarious. So I hope you enjoy this video of me actually taking notes. And then I will, at the end of her video, I will do a summary. Thanks.
Jordan, what'd you get? You got 3. Do we agree? I see 3 over here, 3 over there. Brandon, did you get 3? Yeah. Okay, so number 2 is 3. Awesome. Number 3, Brandon, what'd you get? 1. Who else got 1? Maybe Tara, Jack, and Jordan. 1. Okay. And a lot of you I saw stopped there, which is okay. I know you're still working, but who has an answer for 4? What'd you get, Brandon? 42? I hear 36. And you got 44, so let's check. On number 4, what is D? D says to start with 54, okay? So let's check our facts. M tells us to do what? Subtract 6, which would bring us to 48, okay? M again tells us to subtract 6, so that will bring us to 42. One more time, subtract 6. 36. So some of you got 42, which just means we have one more step. Yep. Good. Okay, and then did anyone get to number 5?
I just
finished it. 6, 6, and awesome, you guys. Good. Let's stop there. Okay, the goal is just to get our brains going a little bit and think about our facts, and you guys did just that. We might pick this up tomorrow morning as a warm-up again. We put it in your folders. You guys add that, and then take your composition books out. Turn to your table of contents, please. So folders and compass.
Here's goldfish.
She's not into my lunch. Probably just
No, actually, open your mouth.
Okay, show me your table of contents. Show me that we are staying organized. That's on Jax. Looks good. Looking good, Flavia. Love it. Awesome, Tyler.
Today's 6/17.
Today is 17. Yes, ma'am. Okay, so for our title, I want you guys to write what's on the board. We're going to talk about parallel lines and transversals. So while you're writing that, what do we know about parallel lines? What can y'all tell me about them? They're little. Hold on, Flavia first.
Equal each other.
What do you mean when you say equal each other?
Like if they're side by side, they could be the same height.
Okay, they might be. They might be just perfectly congruent side by side. That's possible. What else?
Aren't they like in two never-ending lines going in any direction, but they'll never intersect?
But they'll never do what? Say that again.
Intersect.
Intersect. Yes, that's the key there. Okay. Do you see any parallel lines in the room?
Yes.
Where?
Those.
You go point to them.
Even the edge. Sure.
The edge of the board. Okay, right? Because those are never going to intersect ever. Parallel lines are everywhere, right? We can find countless examples in this room. Does anyone remember what a transversal is?
Oh, wait, that's really the ones who do intersect.
They're the ones that do intersect, do cross, okay? So let's watch a short video to warm up, and then we'll get going with our lesson, okay?
Let's get right to it. There's some serious shit about to go down in DC.
Oh, dude, I'm
You're
sorry.
one of the hundred.
Wow.
No!
I like that.
It's fine.
Nice head right there.
I liked it.
We won't tell us.
That did not
Funny.
happen.
U.S. women's
Sorry.
gymnastics knows all about parallel lines. Parallel bars consist of two bars that maintain the same distance from each other and never touch. Sort of like Tom Cruise and Katie Holmes' degree separation. Parallel lines follow the same principle, except that it's more difficult to perform gymnastics using long lines. A transversal is a line that runs through or connects two parallel lines. When a transversal intersects with parallel lines at right angles, it is called a perpendicular transversal, or PT for its letter. With any other sort of transversal, the pairs of angles across from each other, known as consecutive interior angles, will be equal to 180 degrees. Sometimes you might not be totally sure whether lines are parallel or not. Don't let it keep you up at night. We're happy to tell you there's a trick you can use. Look at the corresponding angle. If the corresponding angles are equal, it means the lines are parallel. But if the corresponding angles are different, even by 1 degree, the lines are not parallel. One way that parallel lines are transversal we use in everyday life is urban planning, which includes the construction of roads, highways, and buildings. Deciding the exact route for city streets, including where they will cross each other, requires an understanding of parallel lines and transversals. We're certainly impressed by parallel lines and transversals, no matter what the deal is.
Okay. So what we're going to do first, I want y'all to go to your next blank page in your notes, and we're going to make a set of parallel lines and draw a transversal ourselves. Does this kind of ring a bell for some of you?
Yeah, I know.
Yeah. You're welcome.
It's very nice.
Okay, so the requirements are, in your spiral, you need to make 2 parallel lines. They do not have to be the same distance apart as these. You can draw them wherever you want as long as they're parallel. What would be a good guide to use in your notes to help?
The line.
The blue lines that are already parallel. This is how we got that. Let me see.
You'll steal it back.
Let's use this for now, and I'll steal it back. Okay, so once you have a set of parallel lines, then draw a transversal, so a line going across the two, and make it go all the way as far as you can draw it from page to page. The longer it is, the easier it's going to be to measure. Okay? And when we do that, you can cheat a little bit by looking up at the board, but how many angles have we just created?
8.
8 different angles, right? So I want you to number your 8 angles. Number those. You can kind of follow the order on the board. So I have 1, 2, 3, and 4. And those go in the same order as 5, 6, 7, and 8. So kind of follow that pattern. This group, the order goes in the same pattern as this group. Wait. If you want me to check, let me know.
Yeah. Oh, mine's working.
That's it. Okay, and what I'd like you guys to do is measure all of your angles. So we've used protractors last year, but if you need a little refresher or you want me to make sure we're doing it right, I can come around and do that. So we're going to measure all of these angles. So where do you think you would line this up to measure?
Like on the point.
On the vertex of the angle on the point?
Yeah.
Okay. Do you want me to pull up a tool up here to show you?
Yes.
Okay. Okay, so if you're looking at our protractor, y'all's has a little hole right there at this cross, right?
Yeah.
You want to put that hole over the vertex of your angle. So if I'm trying to measure, I can, I just don't know. Let me go use my computer mouse. I want that it and not the picture. Okay, but let's say I'm trying to measure angle 1. You're going to line up that, for you, there's a hole, but where those lines cross over the vertex. So look at one ray of the angle, it's at 0. And so for me, angle 1, if I follow it up, it goes to about 30 degrees. Do y'all see where I'm seeing that?
Yeah.
So find where 0 is, and then it goes out to 30. I would angle at 30 degrees.
Mine goes up to 40.
That is okay. Ours are going to be different since they're not identical drawings. You drew your own.
There's a keyhole.
How come?
So find where you
Yes.
And number 2
So
would be
like
140,
that's your
right?
vertex. You want this hole right over it. So that line is lining up with 0, and then your angle is obtuse, right? It's a pretty good angle. So when you follow it, yours is about 135 degrees. Do you see that? 135-ish. Yep. I'll check. Let's check. See, if I lined up 0 over here, all the way around, yeah, that one's good. Okay. So what do you think? Okay, first, here's this hole that I'm talking about. It needs to be on the vertex. So where's the vertex over it? Good. Okay, so that black line I'm going to try to line up with the red one. So I'm going to follow it over where it's 0 right here. Coming up to about, what was that? Good. Let's call it about 50 degrees. And you have one? Yes, ma'am. Yes, perfect. What's your check using?
These are very,
Check?
very confusing.
Okay. Are these your parallel lines right here? Okay. There's a lot of lines going on here. We're only going to look at these two and the transversal, not this third or fourth line. Okay? So you said that was 16. Is that what better? That looks about right to me, and that's a cute. Good. Keep going up there. I'm going to erase these little guys. Okay? All right, keep going. All 8 angles. Let's just take a couple minutes.
I still don't know how to say words.
Okay, show me what you're doing.
I'm going to go on the limb and say that that's
Okay.
50.
Which one are you measuring? 5, 6, 5. So you got 0 right here. Okay, so tell me when you think, because angle 5 comes all the way from there to there, right? So about where is it? Yeah. I mean, technically 133, but let's just round it up to the next.
So, what would this be?
So don't move it for a 6 because it has the
Oh.
same vortex, right? But this time come over to 0. And then 6 because I'll go up to here. So it would be, since 0 is on the drawing, you're looking at these numbers, it would be on the 4. Okay? It would take a couple of years.
What's that term? Cheese. Okay.
Show me what angle 1 was. Can you turn it for a second? Oh, the difficult thing here is that it's not actually extending properly, so it's kind of hard to see. What do you think this should be? Yeah. And probably this, if we measured it more accurately, we extended this line, probably wouldn't actually be 40. Well, is it 140 or is it 0 is here? So we're looking at these numbers, so it would also be about 45, right? Okay, so change that and then we're going to 45 as well. You may want to also double check number 2.
So, are most of these going to be like almost the same?
I don't know. Is that what you're finding?
Yes.
Okay. Let's see if it's consistent, because all of you drew yours a little bit different. None of you have come up with the same numbers yet. So we'll see if there's any kind of pattern here. Okay. Okay. No, you're actually going to keep it the same. It's hard because it's video, but there's no time idea. Now, fall over here. That's 0. I'm using these top numbers, which are not there today. That angle goes all the way from there to where? Where's the other side of the arrow? It's about 130 degrees. Yes, ma'am? Whoa. Sure. You can go to any vertex where you want. You can move it down here to the main vertex and then I'll measure those angles. Good. Well, you have 8 angles and so far you've done 4.
How would you?
That was 50 degrees, this was 130.
Wouldn't you like
Okay, that one's
how would you roll
this one.
3, 4, 7?
Which one, 3 or 4? You were looking at 4.
Still doing this. Okay. Yeah, then you go, let's say, this, then just go like that.
How does it come
You're
along?
confusing.
Yeah.
They all have the same thing.
No.
Exactly 45.
No.
That one I would be concerned about because it just has less than 90 degrees. So the other one is saying
I'm alright.
No. You're sure about it?
You know,
yes. And then so following those, if I'm pattern, right? Okay. Let's come together because a lot of you have measured most of your angles, if not all of them. I'm going to pick on Calavia for a second, and I would ask you, will you come up here and label a couple of the degrees that you found using this drawing? Tell us what you're finding. We set protest ban on him. You can bring him up here. Whoa.
So mine seems like a difference of other people's, right?
Right, and why would hers maybe be different than y'all's? She drew it differently, right. I didn't say how you had to draw the transversal, you just drew it at whatever angle you wanted. So it will be a little bit different. 50 and 130, okay. What are some other angles that you found? Will you label as many of them as you can? Go ahead, write it in there. Okay.
And then I got 18 right here.
Okay.
And then
Okay. So no one else had those same exact numbers,
Nope.
did you? No.
I got
I swapped.
one right here.
Good, label well. So looking at what Calavia found, did she find a pattern?
Yes.
Yes. How could we describe the pattern that she found?
So like 1 goes to 4,
Sorry.
2 goes to 3, 5 goes to 8, and 6 goes to 7.
So she's finding some angles that are identical, right? They're matching. What's the word for that? In math, we would say those angles are, start with a C. Congruent.
Alright.
Good. Okay. How would you describe the other angles? Thank you, Olivia. That are not congruent. So, for example, 50 and 130. Is that any kind of special relationship in math? Because those are not congruent, right? But is there anything special about them? Is there a vocab word that we would use to describe them? I've heard this word a lot. We use it a lot this year. So, think. Starts with an S.
Yes, Mommy.
How about this? What angles did you find, Jordan? Your angle measures. Give me a couple. Like, what was your little one and what was your big one?
Well, I kind of swapped them, so 1 and 2 are, like, 1 is the obtuse and 2 is the acute, but
Okay.
1 is 135,
I'm going to draw that here since that's your obtuse one, right?
and then 55
55.
for the acute, or 2.
Okay. And because I know the pattern, it probably should be closer to 45 rather than 55. But are we going to measure these perfectly every time?
No.
No. And some of you, the angle didn't go far enough to reach your protractor, so we had to really estimate and kind of eyeball it a little bit. But y'all, what do these add up to? Guys, if you're Brandon, what do these add up to?
180.
180. What do we call those angles?
Obtuse! No.
What are obtuse angles? You used that word earlier correctly. What does obtuse mean?
It means that the angle is like, well, I don't know the exact definition, but I know what they look like. Acute is what 1 is.
Right. Why?
I don't know. Like, okay, it's because the
Can you help them out? What do acute angles look like?
I'm trying to think of the word. I'm trying to think of the word.
9,
What about 90? Not 90 degrees, because that would
Less
be
than
a
90. Less than 90. And
90.
obtuse is more than 90.
Thank
There we
you.
go.
Thank you. Okay.
Jeez.
So when the two angles add up to 180, you haven't said it yet. What do we call those? Starts with an S. Oh, y'all are killing me. Not complimentary, but
Supplementary?
say that again, please. Supplementary. Okay. Here's what I want you to write underneath our drawing. We can say that when we have parallel lines, guys, cut by a transversal, do you see how half of these angles that Clivia found were 130 degrees? Okay, so I'm going to write underneath this that half of the angles are congruent. And I want you to write that too. So using Jordan's terminology, if I'm looking at what kind of angle are these big angles, what was the word?
Obtuse.
Yes, if I'm looking at obtuse angles, they are all going to be congruent. Wherever I find an obtuse angle, they're going to be the same exact measure. If I have an acute and an obtuse, though, what did we say those are? Complementary, but supplementary. Okay? So the other half are supplementary. It might be mine. Sorry. Okay, so the thing about this is that later we're going to include algebra with this. We're going to have some angles measured with variables and with numbers and expressions. And if you can remember these relationships that either they're congruent or they add up to 180, then we're going to be able to set up an equation and solve for those. Okay? So finish writing that, and then we've got some vocab to cover before we get to the equations. So you guys are going to cut these out. We need scissors and glue. Scissors and glue. Yep. Okay.
How's the reading mode?
I know, we'll get there. I'm excited to keep moving. It's great, isn't it?
It is.
All right, you guys, we have 6 types of angles that we're going to cover. So cut all of these out first, and then we'll fill these in, what the relationship is, and maybe an equation.
You got this,
So you're cutting out 6 rectangles, right? Yep. You can put them together if you want. Your preference, if you want. We're just going to glue them all in your spot. Okay. So have your predictions of what's going to happen in the book?
Summer and August, like, they
you might die.
You think you might die?
All the kids will be sorry.
I think there can be school shooting.
I think that's too, Jack.
You think summer and August might.
Yeah, because you know how Summer said that she already liked somebody and somebody.
Yeah.
I think that she's gonna have to play it off with August as like a favor, and then they're gonna like.
Then it's going to actually turn into something new.
Yeah, it's actually gonna turn something.
I can
big.
see that.
Yeah.
Trash. Thank you.
Derek, you'll be so good with this.
I'll be so good at this. That's
You have your own.
Well, thank you. Okay.
Is that annoying?
I'm looking forward to that. All right, you guys, let's get started. Find the vocab card. Listen, please. It says complementary angles. Complementary.
What you see, us doing this thing or get it past?
There'll be some more people than us.
Never mind, not gonna do it.
On your card, I want you to label these 2 angles, A and B. Okay, so in all of these, we're looking at the relationships between 2 angles in certain types, the first type being complementary. So what would we describe the relationship as? How can we put that into words? What are complementary angles? Do y'all agree with that? They add up to 90 degrees? I need a yes or a no.
No. But yes.
This is a right angle. The 2 angles add up to 90 degrees. Sounds good, Jackson. In the relationship, complementary angles add up to 90 degrees. So how can we write that as an equation? That would be a good specific example. But if we don't know what A and B are, we're going to leave them as variables. So keep it simple. Use A and B in your equation. How would you write that?
A plus B equals.
Love it. Equation A. And I could put the angle sign and keep this little better. So angle A plus angle B equals 90 degrees. Okay, so let's move on to the next one. Supplementary angles. So we have an A and a B. What's the relationship here? Thank you. So this is what we saw in the parallel lines with the transversal. We have a lot of supplementary angles that add up to 180 degrees. So, Jordan, what would our equation be for that?
A plus B equals 100.
Good. And I am going to add the angle notation. Okay, so angle A plus angle B equals 180 degrees. Good. Okay, so the next word, vertical angles, we haven't talked about today, but some of you might remember from last year. Who knows or thinks they know where the vertical angles would be on that picture?
This is your. I don't know, last year, this is.
Okay, in 2015.
Yes.
Anyone want to come up and take a guess at where the vertical angles are?
I know.
Yeah, what does vertical mean? When you think about vertical, what are you thinking about? Up and down?
Straight up and down.
Straight up and down. So let's say I chose this. Where is the vertical angle with this one?
Right. Oh,
Right, straight up and down across from it, right? So I'm gonna put an A here and a B here. Okay. Could I have chosen these two little acute angles? Sure. Those would also be vertical angles. Okay, but it's always a pair of angles that are just right across from each other. So looking at those and thinking about what you drew earlier, what's the relationship there? You don't have to add up to something. What did we find in, let's look at Calamia's example up here. Do y'all see any vertical angles?
Yes.
What angles, Brandon? 3 and 2. Okay? Is there a relationship or any kind of pattern there? They are vertical from each other. What else? How much do they measure? What's this one? What's this one? Okay, test another vertical angles. 1 and 4. This one's 50. This one is. So how do we describe that? What's happening? The vertical angles are always what? Equal. What's another word for equal? How do you see? Vertical angles are always congruent. Okay? What's this little sign? That's an equal sign with a squiggly. That means congruent. Okay? Okay? So for our equation, how would we say that? Angle A, what? And how do you say it with an equation? Angle A. Yeah, so just equals angle B. Does that make sense?
Yes.
Yes? Y'all stay with me. Y'all doing good.
As I go through the summary of this observation, I want to try to use the Gibbs reflective cycle in my thought process of each part of what she did during her class. Let's go ahead and talk about the oops. That's what I like to call it. And I was thinking about cutting it out, but truly, as teachers, we come into situations all the time where things happen in the classroom that shouldn't happen, and it's how we react to them that makes them so important. So the description of what happened is the fact that she was playing a video using technology to enhance the learning, and an ad came up that used an inappropriate word. I handled it as the observer. I cracked up. I thought it was hilarious just to kind of to watch how she reacted to it. So my feelings on that is basically it's not that big of a deal, but it's how we react to it and how we overcome that and how we make changes to that for the future. The good thing is that she just went on. She giggled a little bit, and the kids definitely, loved it because they're 8th graders. But, it's really not as bad of a situation just by using, just that one word. In conclusion, I think that she now knows, and for the action plan part 2, she now knows that she has to be very careful when using YouTube or things like that that are not teacher-oriented. So she could have possibly used TeacherTube or found something on a teaching site that she would have been more familiar with any kind of ads that are popping up. Okay, for the first part of her lesson after the video, she has the students make their own parallel lines and transversal on their paper. She's doing the same thing at the board. Then she hands out the protractors. Unfortunately, these 8th graders are still not up to par on using these tools. So that's when she uses the protractor on the Promethean board, which is a great tool because you can make it smaller and bigger, and she pulls that up and kind of shows them. And then she has them, everybody has made a different transversal. So she goes through and all 5 kids, and she is helping them individually. She also has them come to the board, and she has them use the protractor on the board so they can line it up. She can show them exactly how to line it up, and so you can't really see this, but you can hear her talking to the individual students. Some of the time she's talking to them at their desk, and some of the time she's talking to them at the board while the others are working. So she's not like bringing attention to anyone that doesn't know it. I think Ms. Derricks uses a really, she is really good at letting, using each student and making sure that each student really understands what's going on and how to line it up. And they all automatically are starting to see, wait a second, my numbers are different than this person's numbers. Okay, yes, because we all use different transversals and different parallel lines, and so we're going, everything's going to be different. And then she's allowing the kids to kind of come up with that on their own. Okay, so she's doing a great thing with this part, and so this is a great lesson that she's going to be able to use in her class next year too. Okay, as she continues her lesson, she is using good technology. I really wish y'all could see that part of it, because not only does she have the protractor pulled up, but she pulls up angles, and on those, she's not just drawing them, she's actually pulling them up, and as she's doing that, she is increasing and decreasing the angle, and the protractor is actually moving. The numbers on it are moving according to where her angle actually is. If you notice in this part of the lesson, she really has to do a lot of prompting. These students struggled a lot with math, and they're continuing to struggle even in summer school. So you can see that she's almost like having to spell out the entire word for them, like if she's trying to say supplementary or whatever. So she's doing everything that she can to try to pull everything out. She's writing the different numbers on the board to show them that they equal 180. She is showing 2 angles next to each other to show it makes a straight line. So she's telling the kids, you have the right vocabulary. You used it in the correct sense earlier, but that's not what we're looking for now. So it kind of is a difficult task, I think, for her. As far as my conclusion of that part of it, I would say that for her to, when she's going to do this again next year or this coming year with her 8th graders, I would make sure that they have that vocabulary down before she starts the manipulation of the angles. She's writing on the board also, just in her own handwriting, the notes that she wants them to have in their journal. So kids are writing notes, they're messing with protractors, they're going to the board. She's using these different tools at the board. The technology is really good there, and she actually taught me some lessons while I was watching her, so I hope to use that in my algebra classroom next year. But at the same time, she does way too much prompting. So hopefully with a little more preparation in that, she can find different ways to get the kids to the correct answers without actually having to say, okay, it starts with an S or something like that. The final points of her lesson included the kids cutting out different angles and then writing the relationship of those angles on the card along with the algebraic equations that those angles make. If you watch the video, you can see how she really has to prompt the kids to come up with those equations. Mrs. Derricks is a great teacher. She uses a lot of technology in her classroom. This was just a snippet of some of the things that she used. Summer school for these students went from 8:30 to 1:30. She broke the day up into several different things. They even read a book together. And they had a little outside time, and then they had different technology things that they would do throughout the day. She was teaching them their math. On her board for that day, she even had listed that they were going to do a Kahoot. And Kahoot is where the kids use their phone as interactive technology with the actual website. So I know the kids were really looking forward to that. The kids themselves, most all of them were on task. I would say probably 90% of the time, all 5 students were on task. I noticed one girl didn't say much at all. Like, I don't think she said hardly one word at all while she was there. Ms. Derricks did have her come to the board, and Ms. Derricks did talk to her a little bit one-on-one at the board while the other kids were working with their protractors. I did notice some boys helping each other, and they did seem to be having a lot of fun. And I know protractors, they're not that much fun. However, the conversation that I did hear, I could tell that they were still on task, even though they were kind of goofing off a little bit. It was a good lesson, and it showed me how much more that these interactive whiteboards have to offer. How many of our districts actually have the training. On the Promethean boards that we have on our district, we make these interactive flip charts with the kids, and so we try to make one. Our professional learning community tries to make one per lesson. That gets a little bit of a daunting task, especially when you adopt new textbooks and you kind of have to go and change everything that you've done in the past. But how much technology do all of our districts have that we are not even trained on? I've been using Skyward for years, and I just found out last year that you can do quizzes on Skyward, and it actually grades it for you and drops it into your grade book. That would have been nice to know. So as a future administrator, I really hope that when thinking about professional development with my collaborative team, that we will think about these kind of things that are available to all the teachers, and yet a lot of the teachers are not trained on it. So we'll have those things available to the teachers. I hope you liked this observation video. I know I enjoyed watching Ms. Derricks. She's an excellent teacher. Thank you.